you show my slides now?
Yes, now it is visible. Yes.
So, hello everyone. My name is Sharjeel Anjum, and I am a master researcher at Chungang University, Seoul, South Korea. So today I am going to present my research work as entitled as a pull-up reporting approach for floor opening detection using deep learning on embedded devices. So this research work is done with my co-lab members as the Rabia, Khalid, Muhammad Khan, Numan Khan, and supported by the Professor Chansik. So these are the table of contents that I will cover in this presentation. The first is the introduction of this paper, then the motivation behind this paper, the proposed framework, dataset preparation and developed application, and conclusion. So when we come across the fatal work-related fall accident by different industries from 2011 to 2016, the construction industry contributes significantly to the total sector. There are unseen risks related to construction activities due to confined working environment, where effortful activities are performed that are leading to the accident. So among all industrial accidents, the construction sector workers are exposed to record number of occupational injuries and fatalities. This statistics basically based on the Bureau of Labor, US Bureau of Labor. So if we see on the right side, the fatal work related falls to a lower level, this is because of so many reasons like the ladder, vehicles, roofs, scaffolding. But the most of the cases involve the fully opened openings and partially opened opening at the temporary supporting platform, for example, on the scaffolding and on ground openings. So to overcome this, to overcome the falls from height or falls from the lower level, we are proposing this research work. So the motivation behind this research work, like the construction site is complex and it is dense and large construction site. It is very difficult for the safety manager to go there to construction site and monitor all the things, and this is all the manual inspection process. Also, there are some safety regulations available delineated by the OSHA, like the hole gap and opening should be covered before the work and after the work, so to avoid any kind of the accident. So in this these were the reason we proposed the pull-up reporting approach. The pull-up reporting approach means that which means that the worker is involved in the process to report to the safety manager by using an Android-based application to automate the manual inspection process. If we see, if we see this is the as-is model, like the safety manager has the 2D map for inspection and goes to the construction site and perform inspection of the opening, inspection of scaffolding, inspection of limited access zone, and so on. So this is the time consuming and error prone, and it takes a lot of efforts of the safety manager. So to avoid this process, to automate this process, we proposed a pull-up reporting approach in which the worker has unique registration ID and password. By using his account, he can take the image. Whenever he takes the image, the current location automatically extracted the geo coordinates of the current location, and these images are passed to the deep learning model. We use the YOLO before in this, and this image is classified either as the opening or partial opening, and the classified result with the current location is uploaded to the Firebase database. So this is the basically process flow, how we train the model, how we deploy the model, how we prepare a data set for the this application. So if we see, there are two systems. In this system, we installed the Android Studio. Basically, we use to deploy model by using this system. The data set that we manually prepared and uploaded to the RoboFlow platform that is used to annotate the data set. After the annotation of the data set, we exported that data set with the JSON format and TF record format in this Core i9 system, where we already imported the code to train a YOLO v4 model. And after the training of the model, as we know that to deploy it on the edge devices or we have to convert the deep learning model into TensorFlow Lite model. So we also attack the metadata, like what kind of image size it should take, and this kind of all information to convert that YOLO before model into TensorFlow Lite model. So after the conversion, we imported that model to our local machine, and then we have installed using an Android Studio and export the APK of the developed application to the Android device. And whenever the unsafe behavior is detected, it's upload the all the information, like which worker, the authentication of the worker, which worker has taken that image, and the storage. It enable also the storage and upload the unsafe behavior with the current location of the worker. So in this slide, on the left side, I will explain about how we prepare the data set. On the right side, I will show you the detected results of the YOLO before. So if we look at the left side, we have performed data set preparation using the RoboFlow. We have total 852 images we recorded in the Korean Scaffolding Institute. That was the government institute in Seoul, South Korea. So we went there and recorded different videos for the opening and partially opening, and some of them images we collected from the internet, so because the data set is not open source. So then we imported these 852 images to the RoboFlow platform, and then we perform the dataset augmentation like flip, crop, and rotation to increase the dataset technically. So in the final, we received the 1900 images as a partition of the train images, 1657, and test for the 163, and validation set for the 80 images. So it was like the ratio of 87, 8, and 5 ratio. So if we look at the right image, we can see the detected result of our YOLO v4 based trend model. This inference is performed basically on the trend model. So after this detection, we have converted this model into the TensorFlow Lite model and deployed it on the Android application. So this is the user interface of the developed application. Login. This is login screen and registration screen. This is main user interface. It has worker has two options, like if you want to report by taking using a camera button image, or he wants to upload from the gallery. So whenever he takes image and click on the classify button, it will classify it as either a partial opening or opening. And then when he will click to the upload to server, the automatic on this button, the function basically extract the geo coordinates, and based on these geo coordinates, it will show the current location of the worker. Like we have performed it on laboratory sites. So this shows the location of that site. And when we click on upload it to server, it will upload the geo coordinates and the detected results to the real-time Firebase database. So this is the we can say that the screenshot of our database, real-time database, where the authentication is performed and the storage. So here we can see that the opening folder is created and partially opening folder is created. And also we can see that the opening is recorded at the latitude of this and longitude of 37.50, and same for the partial opening latitude of this, because we test it on the same site. So in the conclusion, this proposed fully opened opening and partially opened opening detection approach is capable to overcome the manual inspection process. The YOLO v4 based detector trained on the custom data set, and that achieved the 86% of F1 score. That shows the model is capable in the detection of foo and poo, and it can be deployed to the construction site. To deploy a trained model on smartphone, the TensorFlow API is used to convert the best YOLO v4 weights into TensorFlow Lite model. Also, the Google Map API is used in the extraction of the geo coordinates of the current location of the worker. And there is a one limitation that I received from the reviewers when I submit this paper. So to overcome this limitation in future, the more dataset will be prepared, and the detection algorithm would be integrated with the built-in sensors to verify the detected foo and poo result, either it is a vertical opening or horizontal opening. So thank you.